Electricity, Part 3. Objectives: types of power sources, series and parallel circuits, current, voltage and resistance, and power. Electric charge is a property of matter that can cause it to experience a force due to an electric or magnetic field. An electric current, I, is a flow of electric charge, Q, where Q is equal to I times T, or electric charge is equal to current times time. The Coulomb C is the SI unit of electric charge. Some materials allow electrically charged particles to flow easily within them. When connected together with a battery to form a complete circuit, the charged particles flow as an electric current. Power sources. Electricity cannot be conducted through a conductor without an energy supply or a force. This energy can be supplied by cells. When the electrons gain this energy, it allows them to move through conducting wires in closed circuits. A cell utilizes chemical energy, which is transferred to conducting components. Two types of cells are the dry cell and the secondary cell. A dry cell is portable. It delivers 1.5 volts, it has a high internal resistance, and it cannot be recharged. While a secondary cell is not easy to transport, it delivers 12 volts, it has low internal resistance, and it can be recharged. Electrons get their energy from cells. This is done by constructing closed circuits. The energy gained by the electrons causes them to vibrate and flow around the circuit. An electric circuit is a complete path in which electricity can flow. In order for an electric current to flow, an electric circuit must have a complete path, a conducting path, and a power source. Before we go any further in this lesson, let's familiarize ourselves with some of the circuit symbols. A wire is made from a metallic conductor, so current can pass from one part of the circuit to another. A cell supplies the electrical energy to the circuit. The larger terminal is positive, while the shorter terminal is negative. A battery is more than one cell. This device converts electrical energy to light energy. This is the lamp. A voltmeter measures the voltage or potential difference between 2 points in an electrical or electronic circuit. An ammeter measures the flow of electricity in a circuit. A resistor restricts the flow of electrical current. It can be used to limit the flow of current to a particular component. A variable resistor, on the other hand, is used to control current. A fuse is a safety device that prevents an electrical circuit from becoming overloaded with current. It prevents electrical fires from starting. A switch in the open position breaks the flow of electricity through the circuit so that no component works, while a switch in the closed position completes the circuit so that the components within it work. A motor changes energy into mechanical energy or gives motion. The earth symbol refers to the point in which an electrical circuit meets the earth. Earthing is used to protect you from electric shock. A transformer is an electrical device which changes the voltage of alternating current. A semiconductor diode is a two-terminal device that conducts current in one direction. Series and parallel circuits. There are two types of circuits, series and parallel. In a series circuit, there is one path for the current to flow. Because of this, if one part of the circuit is broken, no current flows because there is no pathway for the current to make its way back to the other end of the cell. In the series circuit, the current may be increased by adding another cell or removing a light bulb. This is how a series circuit will be drawn using circuit symbols. In a parallel circuit, there are two or more paths for current to flow. If one branch is broken, current still flows in the other branches because there is still a complete circuit without the current having to go through the broken branch in the circuit. This is how a parallel circuit will be drawn using circuit symbols. In a circuit, an ammeter is placed in series while a voltmeter is placed in parallel. A component is anything that can be added to the circuit. It may be a bulb, diode, cell, fuse, variable resistor, ammeter, conducting wire, and so many more. Current, voltage, and resistance. Electricity is like a water hose, where voltage is the pressure the electrons experience in the conductor, current is dependent on the size of the wire or conductor, and resistance is dependent on the material used for the conductor. The SI unit of electricity is amperes. The amount of electricity passing through a circuit is measured using an ammeter. Current, voltage, and resistance are related. It is referred to as Ohm's law, where V is equal to IR. I can be transposed to find that V over R is equal to current and V over I is equal to resistance. Current I is equal to voltage V divided by resistance. Flowing current is directly proportional to the applied voltage and inversely proportional to the resistance in the circuit once the temperature remains constant. Resistance is the opposition to the flow of an electric current. The greater the resistance, the less current flows. The SI unit of resistance is Ohm. Resistance in wires refers to things that can slow down the flow of electrons. Temperature, diameter of wire, and type of metal used to make the wire can affect the smoothness of electron flow through conductors. The resistance of a wire is affected by its length, thickness, and the material from which it is made. Current flows best in short, thick wires. More electrons flow in thicker wires. They also have a shorter distance to travel in shorter wires. Longer, thinner wires have a high resistance to electron flow. Aluminum has a higher resistance than copper. Additionally, wires experience less resistance in short, fat wires that are made of silver. However, because silver is quite expensive, a cheaper but just as effective metal, copper, is used to conduct electricity. Resistors are placed in circuits to control the flow of electrons traveling through them. They also protect appliances from getting damaged by an overload of current, which can lead to electrical fires. On the other hand, variable resistors are used to change the current in an electric circuit by changing the length of the path that the electric current flows through. They are used to control the volumes in radios and television sets and in dimmer light switches. Voltage is provided by the power source. It pushes the electrons or negative charges around a closed circuit. The SI unit of voltage is volts. Voltage is measured with a voltmeter. While electrons gain energy from power supplies, their efficiency may be determined by the rate of their supply. In other words, an appliance is only as good as how well electrons can supply to their demands. The supply of electrons is dependent on the voltage of the power supply and the resistance met within the wires. Voltage could be thought of as the pressure applied to the flow of the electrons within the wires. Hence, the higher the voltage, the more electrons that flow through the wires. Electrical power is the rate of transfer of electrical energy. It is the rate at which work is done. The power of an electrical appliance tells us how much energy is converted in 1 second. The SI unit of power is the watt. Many electrical appliances indicate the amount of power or power rating. All of the equations that refer to the calculation of current are based on the conventional flow of electrons. Here, electrons travel from the positive terminal of the battery around the circuit and enter into the negative terminal of the battery. The fact is, in a closed circuit, electrons leave the negative end of the cell, travel around the circuit, then re-enter the cell via the positive end. And this is referred to as the electron flow. But since all of the equations refer to the conventional flow of electrons, this is what you see in your texts all of the time. Comprehension. In an electric circuit, a current can only flow if... Pause this video to answer this question. In an electric circuit, a current can only flow if a complete path, conducting path, and a power source are present. Comprehension. Label the paths of the circuit below. You may pause this video to answer this question. Congratulations! Did you get it right? I hope you did. What type of circuit is in Figure A and Figure B? You may pause this video to answer the question. Figure A is a parallel circuit, while Figure B is a series circuit. Did you get it right? Congratulations. Comprehension. In the figure, the flow of electrons is depicting. You may pause this video to answer the question. Did you get it right? I know you did. Congratulations. True or false? The SI unit of current is the volt. The SI unit of electric charge is coulomb. A dry cell is portable. The symbol you see there is for a resistor. Adding another bulb to a series circuit will cause the other bulbs to get brighter. You may pause this video to determine which of these statements are true and which ones are false. Did you get them correct? Awesome! So the SI unit of current is the volt. False, because the SI unit of current is the ampere. The SI unit of electric charge is indeed the coulomb. A dry cell is indeed portable. The symbol you see there is a symbol for a lamp. Adding another bulb to a series circuit will cause the bulbs to get dimmer, not brighter. True or false? The SI unit of power is the watt. There are multiple pathways for current to travel in a series circuit. Resistance has units of ohms, and current is directly proportional to resistance. You may pause this video to answer these questions. Did you get them correct? Very good. Yes, the SI unit of power is the watt. No, there is only one single pathway in a series circuit for current to travel. Resistance has units of ohms, and current is not directly proportional to resistance. It's directly proportional to voltage and indirectly proportional to resistance. Fill out the table with the correct units for each quantity. You may pause this video to answer your questions. Did you get them correct? So the SI unit for power is the watt, the SI unit for current is the ampere, the SI unit for resistance is the ohm, and the SI unit for electric charge is the coulomb. Great job, folks. See you in part 4. Bye!